All right, welcome ladies and gentlemen to our lesson 2 of rational functions. We're going to be looking today at everything that we learned in the previous lesson on finding the different parts, and we're going to be throwing into graphing the rational functions. So we're going to list out how to do it first before we look at any of the examples. We're going to find and put on the graph all of the things we calculated in the previous lesson and one minor extra piece. We're going to be looking at vertical asymptotes. We're going to be drawing those as dashed lines. We're going to look at horizontal asymptote, and again, that's a dashed line that we put on the graph. We're going to calculate our zeros, or our x-intercepts of the function. And this is the little addition. We're going to calculate and plot our y-intercept. That's just when we plug in x equals 0. After we have those pieces, we need to test some points, and that way it will tell us what direction our graph is going to go. And what we're going to do is we're going to calculate a value on either side and close to the vertical asymptotes. We're going to plot these coordinates, or do our best to plot those coordinates, at least look to see where they're at. And after that, we should be able to sketch our graph. So, first example is going to look a little bit familiar because it is the first example from the previous lesson. And what I'm going to do here is I'm going to set up a set of axes. If this thing would stop doing that to me. All right, I'm going to put in some numbers here. We got 1, 2, 3, 4, 5. I think that should be good. And we get 1, 2, 3, 4, 5, 6 in the other direction. We need to go down a couple, and we need to go up a couple. We need to go up a little bit more than that. All right, up to 4, down to -2. That should fulfill us everything we need. So let's take a look at the parts. All right, so first of all, our vertical asymptote. As you recall, vertical asymptote is anything that makes the denominator 0. So our vertical asymptote is only 1 in this case. It is x equals -4. Our horizontal asymptote is, because these both have x to the first power, it is the ratio of leading coefficients, and therefore it is 2 divided by 1, which is a 2. Our x-intercept is the number that makes the numerator 0, and if you solved 2x minus 1 equals to 0, we'd add 1 and divide by 2. And so we get the x-intercept of 1/2, 0. And the y-intercept is when you plug in x equals 0, and if we plug in x equals 0, you get 0 minus 1 over 0 plus 4, which is -1/4. So our y-intercept is -1/4, or 0, -1/4. All right, let's put in our asymptotes. Our horizontal asymptote is y equals 2, so that is going to go horizontally at y equals 2. Our vertical asymptote is x equals -4, so it's going to go vertically at x equals -4. And now we are going to start to plot a couple dots. We know that we have an x-intercept of +1/2 and a y-intercept of -1/4. We will do our best to draw -1/4 right there. And now we have to do the new piece. We have to calculate some points. So the vertical asymptote is at -4. When you plug in some numbers close, when I say close, I mean things like f of -4.1 and f of -3.9, because -4.0 is right in between those two dots, those two numbers. So if I plug in -4.1, I get let's see here, 4.1 times 2. -8.2 minus 1 is -9.2. over negative 0.1. And we notice that that gets an answer of 92. Well, we can't really plot that on our graph. However, that does tell us that it's a very large positive number. So it tells us it's way up here on the left-hand side of our asymptote. And so what we're going to do is we're going to use that to know that it's going to get close to the asymptote up here, and then it's going to come down here, and then we know that it has to follow the asymptote over here. So that's right there is the first part of our graph. The second part is when we plug in negative 3.9, so we get 2 times negative 3.9 minus 1, and we get negative 8.8. And when we plug in negative 3.9 plus 4, we get 0.1. So that means I get a negative 88. Well, again, that is impossible to draw on our graph. But again, it tells us that it's going to be way down here, close to the asymptote. We know that it has to come up here and it has to touch these 2 dots because those are parts of our graph. And it has to come up here and follow the asymptote. So we do our best here to follow that. We come up here. Oops, I missed. Let's try that again. And there we have the graph of f of x. Now, is it a process? Yes. Is it going to take some time? Yes. Is it easy? It's not too bad. Plugging in some numbers to find some coordinates and making sure we know how to find all of our original pieces that we learned in lesson 1. All right, let's look at a slightly more challenging function. Again, this is the same function that we used yesterday. So if I set up some axes here to start with, now I don't know the numbers yet, so let's figure them out. I know I have a vertical asymptote. Actually, I know I have it, but I don't know where. X squared minus 3x minus 10 is equal to x minus 5 and x plus 2. So that means I have vertical asymptotes at x equals positive 5 and x equals negative 2. All right, looking at the horizontal asymptote, the numerator is less than the denominator, and therefore it is automatically y equals 0. The x-intercept in this case is when the numerator is 0, and that is a negative 4. And the y-intercept is when I plug in x equals 0, and when I plug in x equals 0, I get 0 plus 4 over 0 minus 10, and I get a positive 4 over negative 10, which is a negative 0.4 if you want that decimal. It is 2/5. And now I have enough that I can begin the sketching. But I need to put in some numbers first, obviously. Let's go, we need to go all the way out to x equals 5, so let's go a little bit farther than that. 1, 2, 3, 4, 5, and 6. All right, and let's go vertically. Let's go up a couple here. All right, let's put in our vertical asymptotes at x equals 5 and at x equals negative 2. So we get 2 vertical asymptotes here. Kind of missed a little bit. You guys will obviously be using straight edges to draw your straight lines. And we have a horizontal asymptote at 0 here. And now we need to plug in our intercepts. So we have an x-intercept of -4. And we have a y-intercept of 0, -1, or 2/5, which is 0.4, which is a little bit close to half. So right in there is good for me. All right, so now we need to do 4 calculations. We need to plug in numbers that are close to the -2 asymptote. So, oops, not f in this case. We're looking at g. We're looking at g of -2.1. And we need to know what is g of -1.9. And again, that's because -2.0 is in between those two values. And if I plug in -2.1, I get -2.1 plus 4, which is 1.9, over, let's see, -2.1 squared minus, let's say plus 6.3 and minus 10 is a 0.71 for us. And if I do 1.9 divided by 0.71, I get about 2. About 2.7. That means it's going to be up here. So it's going to be up in this direction. Now, this particular part is going to be a little bit more challenging because notice it crosses the horizontal asymptote. But what we know, or what we should know, as we are drawing these graphs, it's okay to draw through the horizontal asymptote as long as you come back to it and just go towards it and approach it. Okay, this should not squiggle right here. That's just me drawing a really bad line. That should just come straight down on that dot and through that one. Okay, if I plug in -1.9, I get -1.9 plus 4, which is 2.1, over, let's say, 1.9 squared plus 5.7 minus 10, and I get -0.69. And I get about -3. All right, so that means it's going to be right about here. Now, there are some things that I could do with this particular one, but I need to actually figure out where the other stuff is happening. So if I do g of, let's say I need numbers between or on either side of 5. So I'm going to go g of 4.9, and I'm going to go g of 5.1. And through these calculations, I'm going to save us a little bit of time here. If I plug in 4.9, I get a negative number. And that means it's going to be down here negative somewhere. And if I plug in 5.1, I get a positive number. And that means it's going to be up here somewhere. So, and you could calculate that out. You might as well do it. But to save us a little bit of time here, I'm going to say that that's positive there and negative there. And what this is going to do, so now I'm going to try to do the best that I can here, it's going to tell us that this is going to come up through this y-intercept and then down that direction. And then this one has to follow these two asymptotes. It cannot cross the x-axis because I have no more zeros. And it cannot cross that vertical asymptote. So this has to do this, essentially. All right, so most of these are going to be huge. They're not going to be like great, accurate graphs. They're going to be very rough estimates. But what we really need to do is really need to pay attention to all of the parts as we're graphing it. All right, I'm going to leave us with that. And I'm going to leave you with this, and I hope you learned some stuff on how to graph a rational function, and I will see you guys later.